Okay, I'm looking at the waveforms of the output of the BlueRobotics thruster commander. Channel 1 is the right output. Channel 2 is the left output. And right now the steering and the speed control pots are sitting at center 0, which is sending a 1500 microsecond signal to both thrusters, or will, and that basically the thrusters are in the neutral or off position. I don't know if you can see it, but I can actually read the pulse width down here. And the first thing I'm going to do is play with the speed control, and I'm increasing that. You notice both waveforms are increasing in width. The maximum I can get is close to 2,000 microseconds. So I'm calling that full forward. I just hit the detent in the pot, and they're both sitting at around 1,500 microseconds. Now I'm going to turn the pot in the reverse direction, and now that width of that pulse is right around 1,000 microseconds. And now I'll go back to the detent on the speed control, which both thrusters would be off. Now, when I read the documentation, I figured, well, it became obvious to me how the dynamic steering works, and the amount of dynamic steering is determined on the speed setting. With the speed setting set to 0, you have full range, or the full capability of the thruster controller. So I've got, right now, I've got the speed setting set to center 0. In the real world, neither thruster would be turning. And now as I steer in this direction, which I'm adding thrust, forward thrust on the right thruster and reverse thrust on the left thruster. Yeah, I can keep going. So let me go back and repeat that. Okay, the steering pot is set to the center 0, or the detent. Both are right around 1,500 microseconds, both pulses. So as I add forward thrust to the right thruster, the left thruster is giving what appears to be an equal amount of reverse thrust. So I'll just pick a number here. Forward thrust is sitting at about 1,660 microseconds, and the other one is sitting at about 1,350. If you do the math, I think that means they're just about equal each side of center, which is 1,500 microseconds. I keep doing that until I hit some maximum. That's with the steering the way I have it set up, all the way what I'm calling right, full thrust on the full thrust. Let's see, that would turn me left. Full thrust on the right one, and full reverse thrust on the left one. So this is where I could spin my kayak in place. My thrusters sit on an outrigger setup, and I think, I'd have to measure, I think they're about 4 feet apart. Okay, so now I'm just using the steering. I have not touched the speed control. Steering's coming back to center 0. They're both sitting about 1,500 microseconds. Now I do a right turn. I guess that's a right turn. And once again, this one seems a little bit closer, but maybe not. Channel 1 is sitting at about 1,000 say 1,100 microseconds, and channel 2 is sitting at about 1,900. That's pretty cool. That's how that works. So that's that's the maximum amount of differential steering you can get. Now, if I take my speed control, and I'm going to just set it at some number between 1,500 and say 2,000 on both. That should be about what, 750? So now I'm just about there. 750 microseconds. The steering pot is set in the middle. It hasn't come into play yet. Now as I steer this, what I notice is that the right thruster continues to increase in thrust, the left thruster decreases, and it actually decreases to a number less than 1,500 microseconds. So that means at some point right around here, that left thruster is starting to go in the reverse direction. And it will continue to do that to about 1,350 microseconds, and then it stops. And you'll see how this all comes into play. Likewise, if I reverse the main thrust of the right thruster, the other thruster behaves the same way. In other words, I can get maximum thrust out of the right thruster and some amount of reverse thrust. I say reverse thrust. I'm actually reversing the right thruster, and I get some forward thrust out of the left thruster, but only up to a certain amount, not the full amount. Okay, I'm back to center zero. I've turned the speed to center zero, and now I'm going to pick another number. I'm going to zip my speed up here to 1,850 microseconds. And so I'm going in the forward direction, 1,850 microseconds on both. No, there we go. Now it's 1,800. Now when I change I get a little bit of reverse thrust, but not much. Now when I do my steering, I don't go as far with the reverse thrust. I get a little tiny bit. Somewhere around here kicks in and goes to about 1,410 microseconds. Go back to zero, give myself a little bit more speed. Now I'm sitting at 1,900 microseconds for both thrusters. Now I start to steer. I continue, I max out my right thruster, and my left thruster continues down. And now it stops at 1,518 microseconds, which tells me that when I start with my at maximum speed, 2,000 microseconds with both thrusters going, when I try to steer, I'm never going to engage. The left thruster is never going to actually reverse direction. Likewise, when I go in the other direction, same thing happens. The right thruster never drops back. Well, it's probably sitting right. It's probably stopped, and it doesn't start up again until I get to some point. So I don't know how helpful this is, but it's kind of fun to see it. Okay, put those back to zero. Speed is zero. Steering is zero. I'm sitting at 1,500. Again, one more time just because it's fun. I'll steer to the right or left. My right and left here is... I get real confused. I got channel 1 and 2. I got right and left, forward and reverse. It's real easy to get confused, and I think it's going to be best sorted out once I'm on the water. But It'd be really interesting to see a plot of all this, because these guys have really worked out the algorithms that run all of it, and they've made some choices about where things kick in and where things stop. And I'd be curious to know what the decision-making process was. I certainly don't have any suggestions how to make it any different or why you would, but it's pretty amazing. Well thought out.